Okay, question number 33. So question from topology. So they always ask you at least one question from topology in DSE. So this interval closed 0 to infinity can be expressed as. So by the way, this is a closed interval. Okay, so this is a closed interval. Now what can it be represented as? So let us go by option to option. So open intersection of open intervals a n to infinity. So for option 1, so let a n is equals to minus 1 plus 1 by n. Okay, so this implies that your set a1 will be equal to minus 1 by n, minus 1 by n. So set a1 will be equal to minus 1 to infinity, set a2 will be equal to minus half to infinity, and so on it will go. Alright, a3 will be equal to minus 1 by 3 to infinity, and so on. So intersection of all these AI sets from I equals to 1 to infinity is going to be the closed set 0 to infinity. So 0 is definitely included in all these sets. Alright, so limit n tending to infinity an is going to be 0. So 0 is definitely included in all these sets, whereas anything to the left of 0 will be not included. So option A is definitely true. Now option B, union of these an to bn sets. So obviously you can keep your bn as increasing, alright, and if bn is equals to n, then this union will keep on expanding, but 0 will never be included no matter how an reacts. Okay, so option 2 is union an, union 1 to infinity going from open an to bn, right? So this open an to bn union is so this bn part, if you keep on expanding it, you can take bn equals to n, and this will go on till infinity. The union will go on to infinity, but arbitrary union of this open part cannot become closed. So that's the problem here. You cannot take this union to include 0. So you can take an equals to, let's say, 1 by n, and bn equals to 1 plus n. But even in this case, union of open an to bn will be equal to open 0 to infinity. Okay, bn is equals to 1 by n, sorry, 1 plus n. So in this case it will be open 0 to infinity, so it cannot become closed. This arbitrary union of open set will never become closed. The third part is arbitrary intersection of these closed sets. So arbitrary intersection of closed sets will always be a closed set. So yeah, so this infinite intersection of these closed sets will this bn, yeah, so this is the intersection, sorry, my bad, not arbitrary intersection of closed sets. Arbitrary intersection of closed sets can be so this is not about this being a closed set, because this is actually a closed set, but the bn part is a number. Now obviously if you want it to go to infinity, you want this bn to be infinity, but this bracket represents that bn has to be a number. So as long as it's a number, the intersection of all these numbers cannot go to infinity, right? Because the second part when you take the intersection, it will just take the minima of all these values. So in the third part, you have infinite intersection of an to bn. So this would be equal to, so the right hand limit this would be equal to minima of all the bn values, provided that it's not a null set. It can totally be a null set, but the right hand limit is going to be the minima of all these bn values, which is going to be not equal to infinity. So I want the right hand side to go to infinity, so that cannot happen here. So obviously 2 and 3 are false, so obviously this is true, this is false, and this is also false. So none of these cannot happen, so the only correct option is option A.